Hi.
Hi, Alexei.
Can you tell us a few words about you and about the tool you want to show us?
Yeah, so my name is Niels Bantilan. I'm an ML engineer in the Flyte core maintainers team and also in the Union AI team, which is like the primary contributor and maintainer of the Flyte project. My background's actually in biology and in public health. And I sort of pivoted and did a bunch of different things and ended up in data science and the machine learning field. So here I am. I kind of started off in various, I've been in 2 startups previously. And in those startups, I kind of spent a lot of time like building tools for myself to make myself more productive. And so in service of like building models and whatnot. And I kind of realized that I care a lot about tools and tooling. And so I found myself in joining the Flyte team because I think I'll get into what that whole ecosystem is, but it's basically an MLOps tool that helps you orchestrate tasks and workflows and various compute jobs. So there are a lot of such tools, but I think Flyte is fairly unique. And yeah, so I found myself kind of gravitating toward that and sort of helping building out various extensions to the tool that are more kind of machine learning focused. So yeah, started off in like life science and then now doing machine learning sort of full time and also on the side as well.
So what does Flyte actually do? Is it like for building machine learning pipelines?
Yeah, so Flyte came out of Lyft, and you can think of it, a good close analogy is Airflow. And so, with Airflow, which I personally haven't used actually, but you compose, different operations together in a pipeline, and it schedules it for you, executes it, and there are various integrations with other platforms where you can execute your jobs on like various other like AWS or something like that. And so Flyte is similar. It solves a similar problem. But I think the thing it does particularly well is you can scale up your compute jobs to, tens or even hundreds of thousands of tasks. And because of the various choices that the team made, so I'm not part of the founding team. I joined last year. But basically, Flyte started off as kind of using Airflow and then kind of hacking around it and trying to extend it in various ways. But then the team then decided to go all in on Kubernetes and basically build out a platform from the ground up. And so Flyte itself, you can think of as a multi-layered platform where at the very bottom is built on top of Kubernetes as a foundation, and uses various other technologies like Docker. And really the problem it tries to solve and tries to do really well is each task, which is the basic unit of work in Flyte. Each task is, you can think of as a Dockerized environment. And so everything within that task is reproducible. So the environment is reproducible. There's no like installing requirements and then somehow dependencies, like the external state of the world changes and then, oh, now something is broken inside of it. Basically, a task is this immutable piece, immutable environment where, inputs, it's kind of idempotent in a way, like depending on how you write your task, but same inputs in, you should get the same outputs. And so basically everything, each task is now just completely reproducible. And when you string it together into a sequence of tasks, into workflows, is our terminology, basically you have a full auditability of the entire workflow. And so you can say, okay, this task consumed this previous task's output, which was this value at this point in time. So that's really the thing it does well, from my view, as I've used the tool. And so my role in the team really is to kind of, in a way, stress test the platform in terms of like usability as a user. With my background in data science and machine learning, I basically kind of experiment with it and try to go beyond like the basic training MNIST type demos. And so if we have time, I can show you a little bit of this like online weather forecasting thing that I built. But I can show you also the basic building blocks.
Mm-hmm. Yeah, I'd love to see. So it sounds like Kubeflow pipelines, right? It's also based on Kubernetes.
Yep.
It's also for building machine learning pipelines. So it's kind of similar, right?
Yeah, that's right. We also have integrations with Kubeflow. I think I want to say one of the main differentiators is the SDKs. Like, so we have Python, Java, and Scala SDKs. The Python one is maintained by the core Flyte team. And it's writing, Python code. And it's a kind of a preference or a taste thing. Like, I prefer to write everything in Python and then, configure everything there. And, there is some configuration outside of it, but it feels very much like you're just in Python, just writing code.
Yeah, let's take a look at the demo.
All right. So just get myself set up here. And just let me know when you can see.
Yeah, I can see it.
Okay. I will.
You can enlarge it a little bit.
Yeah, let me just show you this. Okay, cool. So just for context, this is a repo called Flyte Snacks. And it just has a bunch of buildable, runnable examples. So it's a repo filled with these kinds of examples. And this is sort of our hello world. You import FlyteKit, which is the Python SDK. And you can see here that you have this @task decorated function called say hello. All it does is output a string, hello world. And then you have a workflow that just invokes that function and then returns the result. And I can execute this locally. But the first thing to notice is actually Flyte is strongly typed. So again, this kind of draws in the people who like typing, and in Python land at least, typing has been kind of gaining some adoption, and the tooling around that is improving. But this task won't work if you don't actually decorate, if you don't actually annotate the output. You could
it will not work. So it will say, hey, please decorate, or I will not do anything.
Yeah, exactly. So anything that's @task decorated.
For people like me to have discipline.
Yeah. So it sort of like encourages that, or it kind of requires that. Actually, we're working on a pickle type for like any old Python object that's not understood by Flyte. But under the hood, what's happening is I can just execute all of this stuff locally, just as regular Python code. So basics, hello world. Let's see. Let's take this. Yeah, so that just ran just like regular Python. But what happens, I won't get too much into like the packaging and uploading process, but what you do with Flyte is you basically serialize it into this form that's kind of a DAG. And in that process of serializing, you're basically like compiling this code into a Flyte specific language that the team's built. And that language requires you to provide the type information for all the tasks and the workflows. So this will complain during that compilation process if you just have like a bare function that has no type annotation. But this is basically it. Like you can think of anything within the add task. This is just regular Python that executes within the Docker environment that you build for this. But then the workflow is sort of, it looks like Python, but it's a DSL. And as I go deeper into the demo, it'll become more clear that it's actually a DSL and not Python. So just going into a little more like a less trivial task example. I mean, this is pretty trivial still, but this squares a number. And here's an example that uses two tasks, strings two tasks together into a single workflow. All of these examples are designed to be like quite just easy to read off the bat. But you have task one that provides two outputs, and here I'm using the name tuple type. I could do this as like tuple of in string, like so. But here we're using a name tuple. And then we're feeding the output into task two, T2, but only one of them. So we're feeding the second output world here in this case, and then B, which is the second input to the workflow. So you can string tasks and workflows together and compose them pretty simply.
So each of these tasks is run in its own separate container, right? And what is inside this container? Like, do we have any control of what is there? Like, what kind of Python is there? What kind of dependencies are there?
Yeah. So there's a Docker. The user is responsible for building out a Docker file. And the one here is this one. So this is the Docker file for this particular set of examples. And so, in a real world, realistic project, you might, depends on how you organize your repos and your workflow, but you can have, several projects with a single Docker file. The Flyte also supports multiple Docker files per task. So there's a syntax here that I forget the exact syntax, but you can specify a different Docker image per task. If, for example, this one uses GPUs and this one just needs like, a CPU or something. So it's very flexible in that sense as well. Cool. I'll just run through maybe one or two more features, but basically Flyte also supports caching, and this is cache. There are certain caveats to this, the caching mechanism, but basically if I provide the same inputs, the function body won't run, in the Flyte backend, and it will just produce the output that was previously computed. And so maybe now I can go to the console. So if you can check out this console, this is a sandbox environment running locally. And you see I have a succeeding workflow. This is just the hello world example. I can just rerun this. So I can launch the workflow. Actually, let me find something a little bit nicer. So yeah, basic workflow maybe. So this is the console where you can, give some inputs to the workflow, launch it, and maybe you can ask a question right now. This will take a few seconds.
Yeah. So the question I had is where this thing is running. So does it need some sort of local Kubernetes, or it's something lightweight?
So the local sandbox, as we call it, that you can run on your laptop is a Docker container that has a Docker. So we call it Docker in Docker.
Hmm.
The inner Docker container has the Kubernetes and all the Kubernetes dependencies needed to run a Flyte backend.
Okay,
So that system I'm less familiar with, but yes, we have a whole team.
So it's some sort of Kubernetes that you run locally. It's a lightweight version, right?
Yep.
Okay, cool.
Yeah, and so you can see there's a graph here that you can click around and inspect inputs and outputs. So this was fairly simple. You have your start and end node with the two tasks in between. You can look at the task configuration. So this is like very like kind of nitty gritty. You can see the Docker container that was used to run this particular task, etc. So this is the way when a user might interact with the Flyte backend. There is a client that we have to access such a backend programmatically, but that's probably takes that. Yeah, that'll be time for another demo maybe.
Okay.
Yeah, but that's pretty much the basics. There are a lot of features, but that's kind of the basics of Flyte.
And if for a particular task I want to give more CPU because I see that it's slow, I want to make it faster. Is there an easy way of doing that? Because I see there is resources in the thing you just showed. So probably like in Kubernetes, you can say for this job, I want to give it that much resources.
Yes. So actually, I'll just show you this example of the Flyte, this weather forecasting demo that I created. So when you define a task, you can give it requests and limits. So request is kind of like a hint to Kubernetes of like what the pod needs to have when it runs. And then limits is like the absolute ceiling. And these are just the way I've defined these that is up here. So there's a resources object that you can define, and you can give it specification for CPUs, memory, storage. I think it has GPU as well here. And so the backend team needs to provision your cluster in such a way that it has all the resources, but from a user perspective, it's as simple as defining this resources object at the task level.
Yeah, that's cool. So if somebody wants to contribute to Flyte, how do they do that?
It's a good question. So we're constantly working on our docs and easing the onboarding. One of the challenges we've had really is there are a lot of components to Flyte. So this is a diagram of all the different pieces. So down here you have Flyte Snacks, which is that example repo that I was basing the demo off of. And then you have Flyte Kit, which is the Python SDK. And then just maybe finally, you have Flyte admin and propeller. So these are the pieces that what we call the control plane. So that's like the Kubernetes backend that schedules all the tasks and workflows. So short answer is probably the easiest way is to start interacting with Flyte Snacks, which is all in our docs under the user guide and tutorials. And then, looking at it, coming up with examples, checking them out and seeing if you can improve any of the examples or create new ones. And then Flyte Kit, which is the Python SDK, which is also like quite an accessible thing. So it depends on where you're coming from. If you're coming from Python, Flyte Kit and Flyte Snacks would be the place to start. If you're a Golang programmer, Flyte admin and propeller would be a good place. And if you're familiar with TypeScript, there's Flyte Console, which is what this console that I showed you is based on.
Mm-hmm. Okay, cool. And how many people are working on this?
So the core team is about 20 now. But then we have a community of contributors from like Spotify, Lyft, and other partners, and they're also actively contributing.
So quite a few people, right?
Yeah. I think it's about 100 these days.
Okay. What are your plans? Well, what's next for Flyte?
Yeah, there's a lot on our plate. So on my side of things, I'm basically contributing to the Flyte Python SDK and building out more and more examples to kind of like improve the accessibility. And I'm excited. I'm starting to work on a kind of a what we're calling a meta DSL called Flyte Learn. So scikit-learn and Flyte-Learn, the branding kind of worked out there. But Flyte-Learn is sort of a machine learning specific library built on top of Flyte. And people can still use Flyte. It's still very useful, and it's I would say it's, if you're doing machine learning and data processing, Flyte will get you a lot of the way there. But what we're trying to do with Flyte Learn is to almost come up with a minimal API that you can use for both building and then deploying to the web models. So it's still a work in progress. We're still doing a bunch of research to see how best to design this thing. But that's sort of our vision for it, like kind of like a fast API. If you're probably with that, just like something that integrates. Yeah.
So you train a model and then execute one line, and then it's deployed to Kubernetes as a service, right? As a deployment.
Yeah.
That's cool. Do you have any advice for anyone who's watching this?
Besides try Flyte, I want to say, like, based on my experiences in the field, invest in tooling, like, and look at points of where you can make your team or yourself more productive. And part of it requires an investment, right? So like for me, type annotations and typing, like it adds a little bit more of a burden during at the moment. But then once things are in production, like, if the type isn't the right thing, like what do you expect? Or, even data quality, data validation. It saves a lot of time when you're debugging things and trying to figure out where things went wrong. But more broadly, the whole MLOps field, I kind of like where things are going in terms of, de-emphasizing the model and emphasizing all the support around the model. Models still being kind of really important, but still all of the monitoring tools and all of the logging and data quality tools out there. I would check them out and see what makes sense for you.
Okay, thanks a lot. Thanks for joining us today, and thanks for showing us the demo.
Yeah, thanks for having me, Alexei.
Goodbye.